Thanks for joining us today. This presentation is titled The Evolution of Box Furnaces for Heat Treating. What you'll see today is an overview of the standard atmosphere type box furnaces used in today's heat treating market for a variety of thermal applications. My name is Bill St. Thomas. I'm the Business Development Manager for Lindberg, MPH, based in Riverside, Michigan. I'm a lifetime member of ASM and have 44 years of selling industrial thermal processing equipment. Let's get started. This is slide number 2. Oftentimes in the field we're asked by customers how long does a heat treating furnace last. What you're looking at here is a 72-year-old box furnace used for hardening tubes prior to a forming process. This unit is currently installed and operating at an in-house heat treating facility in southern Ohio. What you're looking at here is a rod over bend, a 2,000 degree rated furnace, heaters in the front door. Since obviously it has been the heating lining has been replaced over the years, and the control systems have been upgraded from a contactor type control system to more advantageous and updated SCR type power supply. This is slide 3. The front door is open. You'll see that there is a power connection for the front door, but looking inside, the customer's parts are placed on a rack that an operator typically reaches in with a pair of hot tongs, pulls them out, and feeds them into the forming press. You can see by the sway bar on the lower part of the furnace has been in operation for quite a while, but it's still kicking away. This is slide number 4. This is a list of the key features that are typically make up a box furnace. What we'll do today is review some of the temperature ranges of the various type furnaces, the heating element design, the gas burners that are used in the gas-fired systems, atmospheres that are used in this equipment, the various type of refractory linings, some different hearth designs, and loading methods as well. This is slide number 5. We talk about temperature ranges in equipment. Oftentimes customers say, I need an oven, or I need a furnace, or I need something for temper or hardening, and they really don't know the application or the temperature ranges required of the material that they're using. I've listed here 5 separate processes: tempering, hardening, annealing, carburizing, and tool steel hardening. To the right, you'll see the typical temperature range for tempering. Typically, it's anywhere between 350 degrees to 1400 degrees F. For hardening, we're more in the range for steels, around 1500 up to 2000 degrees. For annealing, it can vary based upon the steel grade from 1400 degrees to 2000 degrees F. Carburizing and box type furnaces are typically done in the 1650 range to 1800 degrees F. And then hardening of tool steels ranges anywhere from 1800, 1900 all the way up to 2500 degrees F. In slide 6, we're looking at a box temper furnace with a very common vertical lift front door. Again, this is tempering, so it could be rated for 1400 degrees. This particular design has a heater box in the rear of the furnace with a fan mixing the heat and so it can go through the heating chamber, and it circulates back and forth. Obviously, this is a convection type application up to 1400 degrees. As you know, about 1400 degrees, the best method of heat treating components would be through radiation. This comes in a variety of sizes. As you can see on the left side, it has a roller rail type hearth where a tray would simply roll in and out, and the hearth line is rather low here, so it might be for a heavier type application. Here in slide 7 is a 1400 degree tempering, which same size furnaces has a workspace of 48 inches wide, 84 inches deep, probably rated for about 6,000 or 7,000 pounds. It has full width churning rollers, so in this application the customer is using a base tray with parts mounted on top of it, and he probably has a roller table in front that he would power in or pull out or push in the large capacity castings. Again, this has a vertical lift door. This particular model is gas-fired. In slide 8, this is a standard box hardening furnace. So this unit would be rated for applications from 1400 degrees to 2000 degrees F. It has a vertical lift door as well, and you'll see that it has a lift cylinder, so it's an air-operated door, and there's also some cam locks to hold the door tight. In this case, this furnace could also be used with an atmosphere, so to hold the integrity of the furnace, we have a door seal on there to make it a gas-tight seal to have any air that might be rushing into the chamber. This is typically used for a nitrogen application, hardies and tool steels. Again, this is an electrically heated unit. In slide 9 here, you'll see a gas-fired box furnace. Again, a vertical lift door, a smaller chamber. This is probably a 24 by 36 by 24. This could be rated up to 2000 degrees or 2200 degrees. You'll see at the rear back of the furnace is a lower part is a combustion air blower, and the gas-fired burners on this side of the furnace. There's probably 2 additional burners on the other side of the furnace to provide the heating for this chamber. Moving on to slide 10, what you see here is an electrically heated 2000 degrees hardening furnace. This particular unit is designed for atmosphere. You can tell because the door has a machine front plate and a slope front door, which provides the atmosphere seal for this type of unit. This unit is also fitted with a top-mounted fan, so it would tell me that you would be looking at a better temperature uniformity, probably plus or minus 5 or plus or minus 10 in this heating chamber. And with the flame curtain, you're now using a combustible gas, which could be endothermic gas or a blended gas, and has the flame curtain as well. These units typically have a skid-type hearth. This size here is a 24 by 36 by 18 workspace. In slide 11, we're looking at a small integral quench furnace. I'm not going to dwell on integral quench furnaces. They are boxes, but they also have a quench tank attached. These were developed in the late 60s, and there's been thousands built by a variety of manufacturers. This particular unit is a small 12-24-10. It's a manually operated system, so you'll see by the small dolly cart in front that you can push this load into the chamber over the quench tank. Inner door opens, pushes it in the heating chamber, and the part is simply removed with a shepherd hook into the quench chamber and then lowered into the quench tank for applications. These are great for small components for ammunition type gun manufacturers, small parts for tool and die makers. Typically the loads are very light. I think the load capacity on this size furnace is probably in the area of about 100 pounds gross. Here in slide 12, you're looking at a larger integral quench furnace. This is a 24-36-24. You'll see that this has the quench tank attached, much like the small IQ furnace in the preceding bulletin. This unit is probably rated for about 1,200 pounds. It has a 24-36-24 gross load. This unit is electrically heated. Again, very popular with a lot of commercial heat treaters and smaller gear manufacturers where the components are smaller. These integral quench furnaces have ranged all the way up to 48 by 72 by 36 for 6,000 pound loads, and even some larger loads made for other applications as well. Probably the most universal furnace out there in the heat treating market today. This is slide 13. What you're looking at is a row of large gas-fired box furnaces rated for 2,400 degrees for 30,000 pound loads. I'll illustrate some more about this equipment later on, but it just shows that the dynamics of box furnaces can be very small for tools or very large. This workspace here is roughly 9 foot by 9 foot by 6 foot tall for 6,000 pounds. These are for some large forging applications. These parts are heated in there in these furnaces, and there's a manipulator that goes in and grabs the work basket and pulls it out into the quench tank that is in the floor position in front of each furnace. In slide 14, you'll see another variation of hardened furnaces. These are 3 stacks of heating chambers used for the hot stamping market. In this particular application, we're taking some very light door frames or door pillars, that are used in the automotive market or deck lids. And what we're doing there is heating the parts in the furnace. A robot comes out and snatches the parts out of the chamber, brings them out rather quickly, puts them into the forming press, which is stamping and holding and cooling the part all in the same press. This application is used today very widely through all the automotive manufacturers throughout the world. These units are rated typically for about 17 or 1800 degrees F. They can be provided with an atmosphere to keep the parts clean. And again, the cycle time or residence time in each chamber is only about 3 to 4 minutes total. In slide 15, this is a very old 2500 degrees atmosphere furnace for hardening tool steels. This happens to be at a used equipment location. The doors are blocked by wood just to show the interior of the furnace. These furnaces were very popular for several years because it provided a higher temperature for tool steels. In the recent past here, these furnaces seem to be supplanted by vacuum furnaces because vacuum can provide the higher temperature application. Most of these furnaces were used for air quenching, so the vacuum furnaces nowadays seem to have at least a 2-bar and all the way up to 10-bar can provide the higher pressure quench, and the furnaces don't have to be idled and they can be shut off and turned on when needed. So these have fallen out of favor towards the vacuum furnace market, but still a vital piece of equipment over the years. In slide 16, you'll see a list of heating elements that are used for atmosphere box furnaces or box furnaces in general. There's a coil element design that is, I'll be illustrating these in the future slides, but the coil elements are used primarily in the tempering furnaces up to 1400 degrees. The rod overbend is a serpentine wire that typically hangs on the walls or the ceiling or the floor of the heat treating furnaces. The core therm heating element is electric core therm that has been designed primarily for carburizing application because it's made of a unique material. And the 2500 degree furnaces that I just illustrated to you typically has a silicon carbide glow bar. In slide 17, what you're looking at is a heating element plug assembly. This is typically used again for a box type furnace. These heating elements are made of a 80-20 nickel chrome wire. It comes down into a plug assembly that is easily removed for repair. You wouldn't have to change all the elements out. You could simply weld up the element that had burned out due to wear, tear, or contamination from some oil if the parts were cleaned. These are very popular elements. They come in little wires, or they're also in a gang of spools that are often used as well. In slide 18, we're looking at the interior of a hardening furnace. This would be rated for 2000 degrees. On the sidewall, you'll see the rod overbend elements that are hung by anchors, and between the two banks of heating elements, you notice the thermocouples. Also in this picture, we'll take time to mention that you're looking at a roller rail type hearth where the tray would roll on these rollers, so this would probably be fitted for something over 1000 degrees where you would roll it in and out. You see the little bridge extension in the foreground here that helps the rollers roll between the table and the heating chamber. This has a vertical lift door. The door frame has a combination of hard brick as well as insulating brick for the seal, but the interior of the furnace is lined with a ceramic lightweight fiber material with probably an 8 or 10 pound density, sprayed with a Ludox material for rigidity, and then it's also used for an atmosphere as well. Quite a popular furnace. In item 20, slide number 20, you're looking at an integral quench furnace that has the core therm heating elements. This is designed primarily for carburizing and carbon nitriding applications in an integral quench furnace. What you're looking at here is a bank of core therm heating elements that is made of a 601 Inconel material that stands up great to carburizing atmospheres. Also, the green coating there is a frit coating that's baked onto the elements prior to installation. This also impedes and slows down any carbon penetration. And of course, the top mounted fan on there is used for circulating not only the temperature and the heat inside the chamber as well as the atmosphere. In this slide, you're looking at a moldotherm embedded pad. These are nichrome heating elements that are vacuum formed in with the ceramic fiber material to form a heating module. These heating modules are very convenient for smaller applications. In this case, this is used in a very large hot stamping furnace as the roof module, and you'll see in another slide that we use the standard and conventional rod over bend type heating element for the bottom element. Again, these are been developed by Lindberg many, many years ago and very popular still today. In slide 21, you're looking at a larger portion of this moldotherm pad. This is again a hot stamping furnace that uses the moldotherm heating element on the top and the conventional nickel chrome rod over heating element on the floor. What you see there are large piers, rows of piers. These would support the body panels that are heated to about 1700 degrees F prior to hot stamping. In slide 22, this is again a photograph of a rod over bend heating element, this time with a skid hearth or a flat hearth used to put base trays in or parts or work directly on the hearth. Again, you'll see a combination of hard brick and soft brick for the vestibule and the ceramic fiber lining on the interior walls. In slide 23, you're looking at a glow bar heating element design. Again, this is a furnace designed for 2500 degrees operating temperature. The glow bars are typically positioned above and below the hearth. This is typically used again with a endothermic gas type generator, and the electric heat elements are used for a radiant type heat as well. In slide 24, we're moving on to gas burners or gradient tubes that are typically used in box type furnaces. Again, this is either an open or direct burner or a radiant tube style burner. You'll see several different variations. In slide 25, you'll see this is a gas-fired radiant tube furnace. These particular tubes are mounted along the rear wall, or mounted on the side wall, and the input gas is from the rear wall. This is again used in a atmosphere-style furnace rather than direct fire. So this would probably be a furnace rated for 1800 degrees F. In slide 26, you'll see a close-up of the photograph that the preceding slide showed. Again, these are the W tubes, as they're typically called. It has a roller rail hearth. This is, again, it's a very old piece of equipment. It is a used equipment manufacturers, but this, again, illustrates what was used in the past. In slide 27, we're looking at an interior of another box furnace. This has a vertical radiant tube. This is again gas fired. These have recuperators, are called SCRs, single-ended recuperative burners. This is probably the most current type of burner that's used for gas-fired type equipment. As a in-between, before these top-mounted radiant tubes with recuperators were used, there was a dimple type tube that was fired from the bottom. The tubes were dimpled to give it some sort of combustion to pick up some heat and to assist in the heating of the product. Excuse me. In photograph 28, you'll see again this large gas-fired box furnace that we looked at earlier. Again, this is a direct gas-fired furnace with the ceramic lightweight fiber lining and a vertical lift door. This furnace was rated for 2400 degrees F for a 3,000-pound load. These again are for large castings and forging applications that are used for the aerospace and the oil field type market as well. These are direct flames, so the flames are typically sent between each one of these piers and fired opposite walls, so you get a good mixing of the gases and the temperature uniformity inside of the chamber. In slide 29, we're looking at a much smaller gas-type box furnace. This will be used for maybe mold burnouts or mold preheating or some forging applications or stress relieving. Again, you'll see the burners aligned along the bottom floor of the furnace. This is, again, a vertical lift door on this unit. The chamber here is probably in the neighborhood of 5 by 5 by 5 with a 10 or 15,000 pound workload. In slide 30, again, this is the large gas-fired box furnace, but with the quench tank in front. Again, this is a hardening application. You'll see the straight-on shot will illustrate the way the piers are aligned from front to back with spacing between. Also, this has a very large cast tray that is in the holding position inside the chamber. Again, there's a manipulator that traverses up and down the railroad tracks there, servicing some 5 or 6 furnaces with a quench tank in front of it. This is probably a polymer or an oil type quench tank, and even water is used sometimes depending upon the steel grades. In slide 31, we're listing the various type of atmospheres. We won't get into a lot of detail, but atmospheres are used in a lot of these furnaces today. Some of the atmospheres, obviously the most common is air, and then for protective atmospheres for various steel grades, there's a nitrogen blended, which we call a 96-4, which is 96% nitrogen, 4% hydrogen. This is a good oxygen getter to keep the parts clean. We also use a nitrogen methanol system, which is typically used with a blending panel. Again, using nitrogen and methanol at various percentages for various applications. The old standby is the endothermic gas generator. And then exothermic gas was another variation of rich and lean applications, primarily for wire and spools and coils of some sort. Also, in the box type furnaces, we use ammonia, as primarily would be for carbon nitride and also nitriding applications, which we are not discussing today in these box furnaces. Also, we can use pure hydrogen and argon. Typically, those are used with a muffle or a retort that we'll illustrate later on in this presentation. In slide 32, you're looking at a rod overbend box furnace, typically rated for about 2,000 degrees with a fan. Hooked up to the system is a nitrogen tank. So this is for some clean processing where the customer would like to keep the scale off the parts. A very simple setup. In lieu of the tank there, the customer may have a bulk tank supply outside, and that bulk tank supply is typically just plumbed into the system. One other thing that nitrogen gas is used for is for a safety gas as well in a lot of these applications. In slide 32, you'll see that there's a blending panel also used with this gas. So in this case, it would be a nitrogen methanol system that's using the process gas, and the nitrogen tank probably is just used as a safety gas. So you'll see the flame curtain in the front of the furnace, some discoloration where the flame curtain is opened, has tarnished the front door. It also has a vertical lift sloping front door as well. So it tells me that, again, it's an atmosphere. This is slide 34, and the next slide following will illustrate a retort that is typically used in smaller applications. These are great for smaller components, wire, smaller parts. Typically, the retort dimensions are probably in the 24 by 36 by 18 range. You're looking at parts of 500 pounds. Sometimes the retorts, in this case, are fixed or placed in the furnace. Sometimes a dolly, if they're small enough, there's a dolly where the retort and a fan plug could also be moved about, and it's moved in and out of the furnace as well. With this, there's typically, again, a blending panel or a variety of gases, hydrogen, argon gases, helium, and things and such, used for whatever the application is and whatever the material grades are. Quite a common kit. What you look at in slide 35 is the same photograph. This time, the front door is open on the reflange retort, so you'll see that the workspace is probably a 24-inch wide, 18 inches wide, maybe 36 inches deep, 18 inches high. This is just typically a heating element plug. These heating element or retort designs, typically are made from a 600 Inconel or a high-grade stainless steel to withstand the temperatures and to maintain the gases inside the heating chamber. In slide 36, you're looking at a light industrial box furnace. This is with the door closed. These are very popular for R&D and lab situations. Normally the changes, this type of furnace is normally set on a table or there's a stand that may have the hardening furnace in one position and the tempering furnace slightly above it as an over-under, maybe even with a roll-out oil quench tank. In slide 37, again, the front door is open. You'll see the muffle that sits inside the heating zone, and again, it's surrounded with the Moldotherm type heating elements. You'll see a very simple plug door type insulated section that closes, and then on the control panel to the right, you'll see a small temperature controller and also probably a flow meter, a nitrogen flow meter that's quite common with these small light duty retort type furnaces. In slide 38, we're again looking at the older 2500 degree box furnace with the slope door. Why I wanted to illustrate this photograph here, you'll see a variety of flow meters that are mounted to the side of the furnace. So you may have a endothermic gas flow meter, probably maybe an ammonia flow meter, a nitrogen flow meter, again, all for various processes and requirements that are needed for tool steels or high-speed cutting tool steels. In slide 39, you're looking at a temper furnace that has a gas-tight shell. This is for, so it is compatible with using a nitrogen gas. So it'll have a continuously welded shell. There'll be a special fan motor seal in the rear of the furnace on this particular unit. Front door are normally clamped to keep it nice and tight to minimize any air infiltration into the heating chamber. These come in a variety of sizes, typically always electrically heated as a rule of thumb when using nitrogen, and up to 1400 degrees operation temperature. In slide 40, you'll see a list of refractory linings. These are typically, over the years, we've gone from brick to castables to ceramic lightweight fiber linings and a different type of hearth piers as well. So those will be illustrated in the upcoming slides. In this slide, number 41, you'll see a ceramic fiber, lightweight ceramic fiber that is used in the roof of this furnace. So instead of having brick arches that were very common for many, many, many years, this lightweight ceramic fiber affords the manufacturer to use a flat type hearth. In this case, there is no fan in the roof, so this would be a 2000 degree furnace, typically probably plus or minus 15 or 20 degrees F. In this unit, you'll see that the front door arch does have some brick to help with the strength of the front door and the vestibule, but inside the heating chamber that there's no arch. It's just simply a span of lightweight ceramic fiber going from wall to wall. Quite popular. In slide 42, you're looking at a 2400 degrees gas-fired box furnace. What's unique about this, there really isn't any brick. That has a poured castable floor in the bottom. This typically is a burnout type furnace for investment molding, so there's some cores that have to be burned out. These are typically gas-fired equipment for 2400 degrees. You'll see in the back is a small stub section. That is the flue, which would take any volatiles or any resins or binders that given off in the molding process and is sent through an afterburner. This has a vertical lift door. This also uses the Moldotherm or the ceramic type fiber type hearth that would be done in 3 sections. So you'll see that the right and left is sort of a skew back, if you will, holding the center section in place. So there's really no brick in this furnace, and this is quite a popular piece of equipment because of the temperature rise as well. It's very easy to replace these modules if they're damaged or broken, and rather than a brick line type furnace. In photo number 44, you're looking at a very older style furnace. This is typically a ceramic type hearth used in the gas-fired furnace. Again, this was a used equipment supplier that had this equipment for sale. You'll see some old hard bricks on the side wall. Again, typically in today's market, those are replaced with a ceramic, lightweight ceramic fiber lining. Even though there may be a cast hearth in the bottom, could be a ceramic hearth depending upon the temperature, the weight of the parts, the type of the parts, and the length of the parts as well. Moving on to hearth designs in slide 44, we talk about a skid hearth, a roller rail hearth, full width turning rollers, fixed piers, or raised hearths. The following slides will illustrate the variations of hearth design used in box type furnaces today. In slide number 45, you're looking at a route over vent furnace. I think we used this photo before, but again, this illustrates a silicon carbide skid hearth or flat hearth that is commonly used in several hardening type furnaces. In slide 46, this is a heavy-duty roller rail type hearth that's used in equipment today. Again, there would be a load table. The base tray would be designed to have a notch or slots in it, the base of this, so it would slide upon the rollers and still provide a heavy-duty type support for any baskets or trays or a large product that would sit directly on the type of the hearth, on top of the hearth. Thank you. In slide 47, this is a lighter duty roller rail hearth. This is actually a oven construction application, but inside you'll see two rolls of roller rails, and then there's a section of, we call this the chain guide casting, where the chain or the pusher head that would go in and attach itself to the base tray to push it in or pull it out is basically there outside the front door for the as a bridge between a load table and the interior of the furnace. In slide 48, this is a front view of a very large furnace system. This had a 48 by 72 by 36 workspace. This was rated for 2,000 degrees to be used with a blended gas. It has two top-mounted fans, but I wanted to illustrate the hearth to you. Again, this is a heavy-duty roller rail hearth. This supported a 10,000-pound load. This particular furnace was also coupled with a quench tank to remove the load from the heating chamber across the rollers down into a quench tank and then submerged and then lifted up. And then there was a load table that was positioned in front and over the top of the load tank to move the load in and out of the furnace. In slide 49, you'll see another variation of rollers. This is called a split roller type hearth. Again, this would be for a flat tray more so than a roller rail. So in this case here, you would use a flat tray that would be able to be reversed and for if it would warp or lose its shape. So you could put a variety of baskets on top of this. And again, it also uses a pusher head or puller head to remove the tray in and out of the piece of equipment. In slide 50, you're looking at a fixed rail type hearth. These are simple posts that go to the base of the furnace, and they're just flat rails that run from front to back. These are typically used when you're using a Big Joe type loader or a small hand truck or high-low type loader, which you would roll it in. The wheels in front of the Big Joe would be keyed to the bottom of this furnace to keep itself aligned, and then you would simply lower the tray onto these rails and then back out the Big Joe forks and then close the door and start your process. This is a very common type hearth used for lower temperature applications and typically lighter loads as a rule of thumb. Slide 51 is a custom design type hearth. It's rather unique. It's a tilting type furnace. This photograph was taken during a rebuild. What you're looking at is a custom type hearth that has side lips on it, but what you don't see, inside the furnace there would be an alloy tray that is connected to two rods in the back. So this furnace is loaded with a hopper, and it sort of just dumps the parts on the load. These are the valve stems for an automotive applications. And then as it's heated, the part is heated up. For time of quenching, there's a trough of water in front, or a tub in front of the furnace. This furnace actually tilts itself up to 45 degrees, and the hearth is vibrated or oscillated back and forth. It actually shakes the hearth parts off the hearth into the water quench tank. It's a rather unique design, and I thought it was worth presenting today. In slide 52, this is the full width turning hearth. Again, this is rollers that can be powered, but typically they're not for lower temperature applications. Those that are familiar with a roller hearth furnace, where you have sprockets and gears on the outside, and the furnace is turned and actually drive the load down through the long section of a roller hearth. This is similar to that, but they are typically not driven. In slide 53, we're once again looking at the hot stamp furnace. These are again for some very light loads, but you may have 3 or 4 parts across the width of this hearth that are picked up by a robot and press quenched or stamped at the same time. Again, this is a lightweight ceramic type design, so there's not a lot of weight, but it also allows for the robot with the end of arm tooling to go in and grab the parts for stamping, and then also loading. The same methodology is used. In slide 54, we're looking at a large box type furnace. This has a fixed hearth. These also look like tip-up furnaces or lift-up type furnaces. This one has a large vertical front door. These are great for large coils of steel, longer parts for tubes, for larger castings. Again, you'll see just a simple, very fixed I-beam base for loading, putting the parts on. Typically, there's a load truck or a manipulator that's paired with this piece of equipment to bring the loads in and out of the furnace. Moving on to various loading methods. We have manual systems where you'll see an older gentleman with overhauls in the old photos with a pair of tongs. Very common today. People using an asbestos suit with hot gloves, pair of tongs to take some parts out of the furnace that is smaller and quenching it in a variety of baths. Just the air fan or oil quench or brine or salts, whatever the quench media may be, is still popular today. Then we talked about the hand trucks, where it's a very portable system that's moved around. We have fixed type load tables, movable charge carts that power itself up between several different common pieces of equipment, and these carts can be push-push or push-pull, with sometimes gearhead motors and pushers in the back wall of the furnace. Large manipulators can be used, as we illustrated in the one application with the large quent tank in front, and then also the robots with end-of-arm tooling is now in vogue today. In photo 56, this is a hardening type furnace application with a very simple roller deck for rolling parts in and out of the furnace. This would be a manual system, very inexpensive, and again, customers like to do this because they have a unique design or tray or part or something that has to go that's placed onto this deck. So the parts that come to this are on a tray as a rule of thumb, and are simply rolled in and out of the furnace and removed from the tray. In slide number 57, you'll see a cast load tray on a table. Again, this is a push-pull, so you'll see some sprockets sometimes moving the parts in and out. Sometimes there'll be a little nose on these trays where the hook will latch on to the tray. This is a very common application for a variety of furnace types as well. In slide 58, you'll see just another photograph of the base tray. There is a bridge extension door, so when the furnace door goes up, that little bridge extension would go down and allow the tray to be pushed across the bridge into the companion type roller rail hearth that's inside the furnace as well. This is a very simple system and often used as a companion kit for these heat treating furnaces. In slide number 59, you're looking at an oven application. What was unique about this was basically the fixed load table in front. This was using a cylinder as a push-pull type mechanism to drive the base tray into the oven and pull it out. Again, very common. In slide number 59, you'll see a little more of a sophisticated gearhead type motor. Again, these are sprockets and gears that drive a pusher head that may have a head on it, or a toggle, or a clamping device, or a pair of pusher heads that actually push driven by a chain, pushes the load in and out of the furnace. In this particular case, this bridges over the top of a quench tank and actually pushes the load all the way into the furnace, and it would probably pull it back out, stop over the quench tank, free fall into the quench. When it comes up, it would engage itself again and pull it onto the table for the next load. In slide number 61, you'll see the face photograph of a roller rails on a chain guide with pusher head. This is a cart yet with the rails on it. These are typically used for integral quench type furnaces. What this illustrates is the pair of roller rails with the proper spacing. The tray has the slotted notch in the bottom of the tray, and then a rack or a tray or a series of trays would fit on top of that. You also see the chain guide casting that rides inside this track here to push the chain, and it retracts and folds itself up underneath. This type of charge car would be used for an integral quench furnace line that would also feed the temper furnaces, the washers, and the integral quench furnace. In slide 62, this is a side view of the cart that we just discussed. Again, this typically would have a set of wheels put on it. You'll see in this case here, there's it looks like a 3-segment base tray that is provided here for this particular load. And again, underneath in the the yellow protected area, you'll see the gearhead motor with the drives and sprockets. And this typically is automated and driven through a PLC system for a lights out type applications. In slide number 63, you'll see the load table that we discussed that had the drive sprocket. So this is a table that's fixed in front. It's up on legs just because it's being tested right now. The quench tank would obviously fit in some sort of small shallow pit. And the furnace is up on legs as well to simulate its final height. This is to test out the mechanical function of the system. But the load table, again, you load some parts on there either from the side or overhead. It would fit on there. It would push itself across the top of the quench tank into the furnace for time for quenching. The intermediate door would open, grab onto the load, bring it out of the quench tank, go into the quench, go through its cycle, come up and drain, and retract itself back onto the load table. Quite popular today. In slide 64, this is for the large gas-fired box furnaces that you'll see on the left there. There's a series of 4 or 5. This is a very large manipulator that drives and feeds loads into each furnace. It's loaded from a charge position at one end, and there's normally an unload position at the other end of this line. This manipulator is driven up and down on tracks. There's normally a festoon system that is attached to this to power the load up and down. Again, this is for 30,000 pound loads for large forgings. Once the load is in the furnace and the heating is complete, at the time of quenching, the vertical door goes open. This telescopes in to pick up the piece of equipment, raising it off the pier, retracts back, and then lowers itself into the quench medium. In slide number 65, in today's market, we've gotten away from all of the material handling systems, manual systems, if you will, for the most part. A lot of customers are going to robotics. This is just one type of robotics. This would be a hardening or a press quenching application where the robotic arm with the end of arm tooling goes in and picks up a part, be it crown gear or a aerospace bearing or whatever that have to be press quenched. So it reaches in, grabs a part or maybe a combination of parts, and then brings it out to the press quench station, which is an oil quench bath with a couple platens or rings to keep the parts flat. This is very common today. This equipment will also pick up a new part and place it in. So it's a complete cell where you're loading and unloading with robotics and taking a human out of the application altogether. In slide number 66, this is our last slide of the day. This is a line with some stacked furnaces. This is at a stamping operation for automotive. This is an R&D center. The 3 furnaces on the bottom are for hardening applications for steel up to 1700 degrees. The top furnace is actually for aluminum parts that also have to be formed by stamping in a press, and that's a 1000 degree or 1100 degree rated aluminum furnace. you'll see once again that the robot can go in and retrieve parts from any one of the 4 furnaces that are lined in the stack. It puts them in the furnace at the time of quenching, go in, has end of arm tooling, actually picks them up, brings them over to the stamping press, and then forms and stamps the parts as needed. Again, thank you for your time today. If you certainly have any questions, I would certainly like to talk to you and answer those questions for you. Thanks for attending.